right, so today we're going to be talking about slope from a table. So if you're a virtual student, your date's going to be a little bit different. It's going to be 10-1, slope from a table, and we are on page 8. So slope from a table is the same concept as slope from a graph. So from a graph, it's rise over run, which is the same thing for a table, but we don't use the word rise over run. It's the change in y over the change in x, and that really is what rise over run is. Okay, so we're going to go ahead and look at our notes today, finding slope from a table. A linear function has a constant rate of change. So if I'm looking at a graph, I know that if it's a constant rate of change, it is a straight line. But for a table, I have to see if it has the same rate of change between each value, because sometimes the table is not always linear. So we're going to be filling this out. Says a linear function has a constant rate of change. Looking at a table, this means the y value, which is the rise, change the, we're going to write the word output, each time, and the x value, which is the run, change the input each time. So our formula, which I'm just going to write it off to the side over here, is the change in y in the little triangle, which you've also seen in science. Instead of writing the word change, it's just a little triangle. So change in y over change in x. So that's the formula for the rate of change of a table or between 2 points. The change in y over the change in x. Okay, so when we look at our table, first we have to identify what the y values are, and usually those are the numbers in the second column, and sometimes it is labeled with y, and it's already given for you, so the change in y is -4. So we're going to have -4 in my numerator spot. The change in x, and again, you want to check all of them, not just the first one, is -6. So -4 over -6. This ratio is not simplified, and negative divided by negative is a positive. So I can make sure it's positive, and then 4 over 6, both numbers are simplified. You can simplify them by 2, so I can reduce this to
2 over 3.
2 over 3. So my slope is actually going to be 2 over 3. If I were to plot these points on a graph and draw a line through it, my rise over run would be 2 over 3. Okay, so let's do some practice. And yes, I know some of these numbers are sort of small on here. So on the first one, remember it's the change in y over the change in x. I'm looking at my y values. What's the difference there? Plus 6. So I'm going to write plus 6. Plus 6. I want to make sure they're all the same on both sides of my ratio. And the number of balloons is my x value, and so my difference there is 2. And the reason I put plus or minus 2 is if you are minusing something, that means you're probably going to have a negative slope. So I always write down if I'm increasing or decreasing as a plus or a minus sign. So it's the change in y over the change in x. So again, I'm just going to write this once just so you can remember the formula. Change in y over change in x. So this is 6 over 2. 6 over 2 can be simplified to 3 over 1. Or you might see it written as 3. So the slope would be 3 or 3 over 1. On the next example, remember my formula, change in y over change in x. So I'm looking at my y values from $25.50 to $42.50. My difference is 17. So plus 17, plus 17, plus 17. t, so the differences between all of my y values is increasing by 17. My x values are increasing by 2, so I'm going to write plus 2. So my change in y is 17. My change in x is 2. 17 over 2 is improper, but since we're dealing with slope, that's okay. And I leave it like that. 17 over 2 cannot be simplified. Next example. So remember, it's the change in y over the change in x. I'm looking at my y values, so the difference in my y values are from 8 to 0, 0 to negative 8, minus 8.
Yes.
So I am decreasing by 8. And then for my x values, what's happening?
Plus 2.
Plus 2. So I'm going to write plus 2, and it doesn't matter which side you write it on. So then my slope, change in y over change in x, is negative 8 over 2, which can be simplified to negative 4 over 1, which can also be stated as just negative 4. Hey, so on the last one, this one's a little bit different. That's why you always want to check the number. So if I'm looking at y from 50 to 10, that decreases by 40. So you're going to write minus 40. From 10 to negative 20, that decreases by 30. So I'm going to write minus 30. From negative 20 to negative 70, that decreases by negative 50. Okay, and then I have to check my x. From negative 10 to negative 2, that increases by 8. So I'm going to say plus 8. From negative 2 to positive 4, that increases by 6. So I'm going to say plus 6. From 4 to 14, that increases by plus 10. So some students get to this point and notice there's numbers difference. They automatically assume it's not linear, but you need to check all your ratios to see if your ratios are exactly the same. So negative 40 over 8. Negative 30 over 6. Negative 50 over 10. If I reduce all of those are equivalent to what?
5.
Negative 5. So yes, it is linear. That's why you need to check it all. So my slope, or my rate of change, is negative 5 or negative 5 over 1. Okay, so whenever you are done with the notes, you are going to glue it in your journal and make sure you title it Slope from a Table.